right. Hi, everyone. Welcome to tonight's meeting of the Hand-Eye Supply Curiosity Club. We're your hosts this evening. I'm Tobias, and this is Will. Together, we have a number of curious and exciting topics to share with you.
As attendees of the Hand-Eye Supply Curiosity Club, you are all now members, provided you adhere to our philosophy, ex curiositas scientia. We pledge to learn without prejudice and pursue our mutual goal, perpetual novice. We admit that it is impossible to know everything about anything, thus we remain perpetually curious and perpetually novice.
This is our flag and our mascot, Franklin. The lightning bolt represents the receipt of knowledge, the enlightenment of illumination, and the resonance of truths understood. It awakens and excites us and makes us hungry for more. And now, let's give a warm Curiosity Club welcome to Joshua Lifton.
Cool. Thank you. Thanks for coming out. And thanks to the Curiosity Club, Will and Tobias, for having me. I think this is a great forum for random thoughts that people have, that kind of long form, which this will be. Apologies ahead of time. I might be chewing on menthol for getting rid of that last dry itch from the cold last week. But here we go. So 5 years ago, I guess, I discovered stenography. And I'll tell you exactly how in a second. Stenography, though, is pretty old relative to most technology we use today. I think it depending on who you talk to, it's from the early 20th century, maybe even late 19th century. So it's over 100 years old. This is a World War II flyer recruiting stenographers for the war effort. And it's been used pretty consistently, even from its inception, even till today, for government work, in courtrooms. Or the people hunched over a funny-looking machine like this, and transcribing everything everyone says. So when they're called the court reporter, right? And they're transcribing literally every word said in the courtroom. So whether it's the judge or the witnesses or the jury or whatnot. The origin of stenography is in shorthand. This is an example of something called Gregg shorthand. And shorthand is essentially an acknowledgement that our written system is not very efficient, right? The English language specifically is not a terribly efficient written system. There's lots of extra letters that we get, from French or German spellings. But shorthand is really, how do you get it to be the most efficient? And so this is what a lot of reporters use, a lot of secretaries used to use, and some of them still do probably. I don't actually know what this says, but this is what you'd write down with a pen, right? So if you see somebody scribbling madly, they can often get faster than typing speeds. So I know somebody who he reported that he was getting about 110 words a minute. And as reference, I think the fastest QWERTY typist, keyboard typist, is about 130 words a minute. On a good day, I'm maybe 80 for short bursts, but usually I'm like 60 or 65, and I type pretty much all day.
Are those
Yeah.
each a word or a letter?
These are, they're not each letters. No, it's phonetic, I believe. And that's we'll get to that in a second. But yeah, also please interrupt with whatever questions you have. Lots of different places we can diverge to. So a stenotype machine, and this is a picture of this very one, and I got it at Goodwill when one of my friends alerted me that it was there. And I rushed over and got it for like $20. I think this was made in 1920, and it's essentially a mechanical version of shorthand, right? So it has some levers here which kind of indent a roll of paper that would be here on the back, and it's purely mechanical. There's no electrical anything in it. As you type, those levers imprint on the paper, and the paper rolls, right? Now, what you're doing here is you're chording. So it's like piano playing rather than typing on a QWERTY keyboard is this keyboard here, right? Oops. We'll get our picture back in a second. QWERTY, does anybody not know what QWERTY is? Why it's called QWERTY? It's QWERTY. It's those first letters on the top row, right? And QWERTY keyboards are, despite the fact you have your hands on them the whole time, you're only pushing one key at a time, right? Unless you're doing like shift something. But really, you're just doing one key at a time. And this, you're typing many keys at a time, right? Up to 10, or actually more, potentially, if you're pressing more than one key with one finger. So already you can see where the efficiency comes from, right? You're really like compressing information into a chord rather than a single key press, which take the same amount of time. So this is a fairly typical, well, in fact, there's only one keyboard layout for stenotype machines, and that's it, this one up here. There are different companies that make them and whatnot. Like I said, it's essentially piano playing plus a regular computer keyboard equals stenography. So it's very fast. You're getting, the world record is 360 words a minute with a stenotype machine. A professional stenographer is rated for at least 225 words a minute, usually more. And typical speech is less than that. In a conversation, a professional stenographer can capture literally every single word that's said. A voice writer technology is meaning if a computer is listening to me speak and it's trained to my voice, can get about 180 words a minute. A Dvorak keyboardist. A Dvorak is another keyboard layout for your standard computer keyboard, which is slightly more efficient. Can get about 100, I don't know what this says. It's about 20% more than, or 10% more than the QWERTY typist. QWERTY is what almost everyone uses today, right? That's this keyboard here. The average typist is around 50 words a minute or so. And of course, handwriting is much less than that. So let me show you a video. This is off of YouTube. A collaborator of mine, Mirabai Knight, who is the person that got me interested in this in the first place and is really a driving force of this whole project, recorded herself on this website called TypeRacer, which is a place you can go if you want to compete against other people to see how fast you type, right? It's actually really fun, despite what I just described it as. So let me just show you, there's no sound to this anyway, but this is Mirabai racing somebody named Jimbo, and they're typing this here. You can see where Mirabai is with the letters turn yellow, and you can see at the top in the upper right-hand corner the words per minute. So she made one mistake. She's going at over 200 words a minute, or she will be in a second. And the other person is a really, really fast QWERTY typist and got up to like 110 words a minute or something like that. So there's a lot more of those videos if that was really your thing. So why would you want to do this? Obviously, it's good for typing fast. This is taken directly off of our webpage at the Open Steno project. These are blog posts written by Mirabai as to why you'd want to do this. But I think she breaks it down really well, which is why I just copied it verbatim. One is it's really powerful to speak with your hands, right? Right now, we can have a conversation face-to-face, and I can talk as fast as I want to, and you can talk as fast as you want to, and we'll understand each other. But somebody who can't talk, it takes a lot of effort to communicate, right? You either have to write something down or type it out. So as an example, Roger Ebert, who just passed away a couple years ago, he's the Siskel and Ebert, Roger Ebert, right? So he's the thumbs up, thumbs down guy, movie critic. And he, if you remember, he had throat cancer. He had to have his tongue and lower jaw removed. And so he could not talk at all. And so he was using a standard keyboard with some very sophisticated software written specifically for him that really well emulated his voice, right? They like did a great job of emulating his real voice, but it was slow because he could only type so fast. So he couldn't have like a real fluid conversation. So that's one reason you might want to use this. You could have as fluid of a conversation as you wanted because you can type faster than people can talk, right? So that's one really good reason. Of course, the number of people who you'd want to do that with, or that would be useful for, is fairly small. But we shouldn't discount them, and there's plenty of them. So if you can't speak but your fingers work fine and your mental facilities are fine, this is a good solution for you. Second reason, if you do a lot of writing or coding or spending a lot of time at a keyboard at all, the efficiency will really add up over time, right? I spend most of my day in front of a computer, and I'll be the first to admit that my blocking thing isn't how fast I can type. I can type pretty fast, but over time, that would add up to a huge amount of saved energy and time and mental facility, right? I mean, how many times have I misspelled a word and had to delete a bunch of stuff? And so if you spend a lot of time in a computer, which a lot of more and more people do, this is also a great thing for you. Ergonomics, if you've had wrist problems or anything, oftentimes it's because you're doing this, right? You're like hitting your control key and then this, and whereas with stenography, your hands never really move. Your fingers move like this. And it's really telling to watch a professional stenographer versus a keyboardist, a QWERTY keyboardist, because the professional stenographer is going much, much faster, but their hands are barely moving. They're really just like hovering over the keyboard, and their hands aren't moving at all. It's just their fingers, right? So much less stress. Yeah. Yes. Yes, I'll get to that in a second. Yeah, but absolutely, yeah. So there's a strong ergonomic argument as well. If you're interested in wearable computing and kind of augmented reality, virtual reality, there's not a lot of people that dress up as gargoyles from Snow Crash these days, but those that do have these twiddler things in their hands, like these cording keyboards. And there's some people who can go pretty fast, but after decades of use. But it's very inefficient, and I can imagine something where you just have something very wearable that emulates this, and suddenly you're inputting text as quickly as you can think it, essentially. So interesting wearable component there. Like I said, the raw speed is the ego thing, perhaps. And then there's professional stenography, and this is what it's used for today, almost exclusively. Almost no one does this just for fun. Not the best endorsement, but I'll tell you why in a second. And professional stenography is basically divided into three sections, right? There's CART, captioning in real time, I think, is what it stands for, which is used in a lot of accessibility situations. So by federal law, if you receive money from the federal government to run your school, and a deaf person or hard of hearing person enrolls, you're required to provide them with a captioning service of some kind, whether that's a signer, a sign language person, or somebody who more likely captions, sits in the back, listens to everything, captions it on a STENO machine, and then it shows up on the person's laptop or on their device, right? So the person can follow the lecture in real time and get all the information that they need. This is what my collaborator Mirabai does professionally. She basically gets paid to go to school to listen to very interesting classes from everything from neuroscience to pharmacology and who knows what else. So that's what she does for a living. Then there's court reporting, which is what I described earlier, where you are sitting in a courtroom, you're transcribing the entire proceedings, and there are a couple of categories of that. You might be in for a deposition, you might work for a law firm taking depositions, but it's all around law. And then there's captioning that you'd see on TV, right? And this is what I think a lot of that's being replaced by computer programs now, and you can kind of tell when they make funny mistakes, right? I don't know how much of that is actually done by stenographers anymore. So why isn't anybody doing this, right? And the answer is really simple, right? It's very expensive. Even to get started on the software alone, let alone the hardware, is $2,000 to $4,000, right? And it's proprietary software, meaning you can't really copy it to another machine if you need it to, or you can't give it away. You can't inspect how it works. So if there's something you don't like about it, which invariably there will be, you can't fix it, right? And worst of all, it's a walled garden on your computer, meaning, let's say you buy the software, you install it on your computer, you have a STENO machine. You can only use the STENO machine when inside this software, which means you can't use it, for example, to write an email in your email client of choice, or browse the web, or write a letter in whatever program you want on your computer. So it's really just a purpose-built piece of software. It really locks you down. We solved this problem. This is how I got into this whole thing. There's something called plover, which is a type of bird, but it's also unique in the stenography world because I think it's the only. You have to ask Mirabai why it's unique. I don't really know. I think it's the only one-stroke, 6-character word in her dictionary or something like that. But Plover was an open source program, and this is how I got started in this. Mirabai was working in the co-working space that I worked at in New York when I was living there at the time. And there's one elevator going up and down, and she posted a little ripped off corner piece of paper on the bulletin board in the elevator saying, I want to learn how to program in Python. And that's what I was doing at the time. And so I responded to the email address, and I said, yeah, I can tutor you in how to do this. And much to my surprise, she was going to pay me, which was great. So I was getting paid for this once a week, I think, for an hour or so. And she had tried to learn Python before, and I quickly realized that the only reason she wanted to learn how to program was so that she could write this one program for stenography. And she had no interest in anything else. And so I was like, well, OK, why don't we just learn how to write that one program, and I'll teach you what you need to know to do that. And so we started doing that for a couple weeks. And then that was pretty slow going. She had almost zero experience with programming. And then more and more, I'd be sitting in the chair, and she'd be watching me code a little bit. And then eventually, it was just me coding. And then eventually, she stopped showing up, right? And then I realized what was going on. And I was interested enough, and I was like, wow, this is actually really interesting. Stop paying me. Let's make this open source, which you wanted to do anyway. And I'll just try to get it out there, and we'll see what happens. So that's what we did. Plover is the result. It now has a community of several hundred people who use it pretty regularly. Some of them, Mirabai uses it professionally, so she's replaced her $4,000 software with this, and it's way more functional. I've since stepped out of development of Plover, as much as I like doing that, and someone else has taken over. Heskey Fisher has been doing a great job leading that, along with a couple other people who've contributed. And that, for me, that's a huge success. If you can start a project and then hand it off to somebody, and they still want to do it, and it still lives, that's such a gratifying experience. So that's been great. The next problem is the hardware, which again is really locked down. There's only handful of companies that make machines these days, and this is a very old one. I think this company still exists. I'm not actually sure. But for a professional machine, and there really only are professional machines, because again, nobody does this for fun, really. It's going to cost you between $1,000 and $5,000, say, and that's without the software. You can't really, none of it's open source. It's the same problem as the software, right? If you want to improve something or make it better or share it, you can't really. So this we initially solved by recycling computer keyboards. And there's a certain kind of computer keyboard called a gaming keyboard. A gaming keyboard is maybe twice or 3 times as expensive as a regular computer keyboard. So this one runs about, this is called the Sidewinder keyboard. It runs about $60. You can still buy it today. And it's special. Gaming keyboards are special because you can mash all the keys at once, and the computer will register all of them, right? Whereas with most keyboards, such as the one on my laptop or the ones that you probably have, if you mash all the keys, it'll only pick up a certain number of them, but not all of them, right? And for gamers, it's called gaming because gamers, it's really important for you to like mash all the buttons at once to win. So we use that, and we you can see here, there's some of the little pads that have been laser cut out to emulate a stenotype layout. And so we just put in a mapping in the Plover software, so if you're using one of these keyboards, it will translate it the right way, and you'll get stenotype or stenography out. So again, so for about $60, we'll get to this in a second. So you can go out today and use this and try out Plover and get a feel for what real stenography is like, right, for $60. And then the third reason why nobody really knows about or uses stenography is that it's really expensive to learn, right? I mean, there are schools out there that only teach stenography. The graduation rate is, I think it's either 10 or 20%, right? Meaning, I mean, think about that, right? Like somebody's spending college level tuition at a vocational school, and only 1 out of 10 of them make it, right? And the others just are saddled with this debt. It's really horrendous, right? It's just like, it's amazing that it's still like this. So, and the minimum time is about 2 years. If you are really just naturally gifted, you might get out in 1.5 years. If you need a bit longer, you might be in there 4 years. Don't really know. But the only way you get out is if you pass the test. If you become a certified professional stenographer, which is 225 words a minute or higher, right? The community is kind of organically getting around this by teaching each other, right? There are some professional stenographers in the Plover community. There are people who are just picking it up for the first time. There's actually a guy who started with Plover and is now a professional stenographer. And I think he's the first one, Stan. Hey, Stan. And he just took off. He loved it. He knew Greg's shorthand before, I believe, and he was studying to be I think a pharmacist or a linguist, and he found this, and he's like, this is what I want to do. He was in a pharmacy school. He decided that wasn't for him, and then he went into linguistics school, and then he found this, and that's what he does. So he's in New York being a professional stenographer now. And people have written, there's a book out there. There are numerous play, kind of like a Guitar Hero style games where you have to type in order to stop the thing from falling. So that's really great. And that's how I know that the community is really alive. The project I'm here to talk about tonight mostly, this is kind of all, for me, this is all the past history, and now I'm working on STENOSAURUS. And STENOSAURUS is something I thought about the very first time I sat down with a stenotype machine with Mirabai, 5 years ago. And when I realized how arcane and locked down and backward all this technology was, I was like, this is like slim, easy pickings for some innovation, right? And when you think about it, it started 100 years ago. It went digital finally in I think the 80s, right? So you can now hook it up to a computer and use software, but it hasn't really changed since then. And so the STENOSAURUS is kind of our vision of what it should be, right? And what it should be is something that is, looks like this. There's a couple keys missing. This is a prototype. I should say, all the physical things you see here of STENOSAURUS were made by Kurt Mottweiler. He's my collaborator here in Portland. He is a genius maker of physical things. He's spoken here before about his other things. I highly recommend checking it out. But he did the design of the keys, the case, all of the physical stuff. And I'm working on the software and the electronics, which I'll get to in a second. So this is a prototype. What it should be, what stenography should be, is something that is less than $1,000. So we're hopefully getting to the $300 price point with this, which is about what a very fancy keyboard costs these days. It plugs in via USB, right? You don't need to install any software on there, Plover or otherwise. All the intelligence is in the thing itself. And so you just type here, and what your computer sees is just text spewing out, right? And you were alluding, I think, to the question of, well, how does that translation process happen, right? So let me go through a quick example, I guess. Yeah. Yes, yes. So there's a reason professional machines actually cost a lot, and it's not a bad reason. They're much fancier than this is, right? This machine that we're making, the reason it's cheap is because the keys are essentially repurposed mechanical keyboard switches. And when I say mechanical, I mean this is the switch underneath. It kind of has that clicky sound, right? Think back 20 years ago. That's every keyboard had that, right? So we found a manufacturer of mechanical keyboard switches called Matthias in Canada, and they've been willing to make a keyboard switch that's specific to the STENOSAURUS, so to our specifications in terms of how hard you have to touch, right? And the answer is you want it to be as light as possible, right? So just barely anything at all. And it should also be very quiet because you're in a room listening to people. You don't want to disrupt them, or you don't want to be disrupted yourself. Yeah, you don't want that clacking sound. So this switch that we're getting made that should be ready by the new year or close into the new year will be about 35 grams of force to activate it. Now, where you activate it, how hard you have to push will be constant, right, across all the switches. How far you have to push will be the same for all switches. There's really no knobs you can turn here. A professional machine, all of those things are adjustable and many times. So not only how far down you have to push it, but the actual force you have to apply as well. And there's a couple other parameters I think you can change as well. So that adds up in a lot of cost. And those machines don't use this key switch type mechanics. They use a lever system almost always, right? There's a notable example called the Lightspeed, which is it's either capacitive or I think it's a light sensor that senses when your finger is over the thing. So there's good reason to make it expensive. I think we can get to 90% as good of that for 10 times less, right, in cost, which I'm happy about. So right, how do you translate from finger movement to English, right? And it's essentially the same as the shorthand, right? It's the same theory throughout, right? From the very beginning until now, the theory really hasn't changed that much. And the theory is one of phonetics. So you listen to a word, you don't need to know how to spell it, you don't need to know what it means. And training, the reason it's difficult is you've trained your fingers to just automatically you do it, right? And so you break it up phonetics. This left-hand side of the keyboard, where your left hand would be, is the initial consonant of the phoneme. The right-hand side is the final consonant, and then the 4 keys on the bottom are the vowels. Okay. Now there's 34 keys on here, but in reality, this entire top row is a single key, logically speaking, right? So if I press this, it's the same as pressing this one, or as any of the others on this top row. Similarly, these 2 keys are logically the same. think that's it. I should say I don't know how to do this yet, by the way. I've been working on this stuff for 5 years. I have no idea. I mean, when I test the software, I just learned which keys to press to get kilogram, I think it was. And if I could get that, I knew the software was working, or I kind of figured that it was working. But I can't. I will eventually learn how to do this. So you. So I don't know on this. I know on my laptop, because that's what I was testing it on. So when I showed you the Sidewinder keyboard, that's what I was testing with. So let's take an example. Catalog is a good example, right? Catalog would be, I believe, 2 strokes, one for cat and one for a log, right? And you would first, and by stroke I mean a chord, right? You first chord the phoneme for cat, and then you release, and then the word cat would appear on the screen, right? And then you would chord the phoneme for a log, and then the software, whether it's on this or on your computer, would realize, oh, this is the phoneme for log, but because it came after the phoneme for cat, in my dictionary, there's something that's both of these consecutively, right? And so I'm going to prefer this because it's more complex, and that's probably what they meant, over just cat and log. And so they're going to erase what is the cat and then replace it with catalog. So there's a lot of intelligence in how the English language is constructed and how you make sentences and capitalization and all of these things. But essentially, the theory is purely phonetic, and then there are different theories. This is where the theories diverge. There's different theories for how to speed things up with mnemonics, right? So if there's, and these are called briefs in stenography. So you might have a brief for, I mean, essentially you can make up your own mnemonics, right? If you can remember that, Constitution is just con star or something, then good for you. Just keep remembering that. But there are theories of mnemonics as well that will teach you how to create mnemonics, and that's where all the theories diverge. And I don't know how many theories. There's I think at least a half a dozen different schools that you can go to that will teach you a slightly different variant. And I mean, it's kind of like romantic languages, I think, right? One stenographer who learns one way might be able to kind of get the meaning of another theory's stenography, but not the exact specifics, right? So kind of Spanish, Italian.
Examples of words, like how you break those up, like for just whatever. Like, I thought that was very interesting, like Constitution.
I don't really know. I mean, that's
Like baby, would that be like baby? That'd be 2 when you press the chord be 2.
it's basically syllabic, right? So if each syllable is one chord, kind of. That's my understanding of it. But unfortunately, I can't really answer that because I haven't gone down the path of starting to learn, right? What I do know is that each stenographer has their own dictionary, right? That their own lookup. By dictionary, I mean a lookup dictionary where here's the chords that here's the key presses I just chorded in, and here's what I want to be spat out, right, on the other side. And so the computer, whether it's inside of this or on your computer, will, every time something is typed, it will look up in this dictionary, which oftentimes is 100 or I think the default dictionary with Plover is around 300,000 entries. I don't remember exactly, but it will look it up and then spit out that text. And that text can be whatever you want it to be. And this is getting to your question, right? It can be a word according to your phonetic theory, but it could also just be the Declaration of Independence, or a book, or it could be code. It could be a special symbol. It could be whatever, right? And so as long as you have that theory in your head and the mnemonics behind it, you can put arbitrary text, arbitrary strings of text in your dictionary. And so this is how coding would work, right? If you want to code with it, coding is, if I'm programming a computer with this, there's a lot of just rote boilerplate, right, that I have to put in. It'd be nice to have that all automated, which is, there have been some examples of people using it for that. It's really my goal with the STENOSAURUS is to reach out to people who are not going to be professional stenographers, but who might use it for programming or might use it for just their daily job and their daily life. And you don't need to get up to 225 words a minute. 120 words, I'd be thrilled with 120 words a minute, right? I mean, I think most people would. So let me show you. Oh, right. So I sat on this idea for, I think, 3 years, and I was just like, and finally, I think I was taking a shower, and it struck me, the logo, right? Or the name, actually. The name struck. I was like, STENOSAURUS, that's what I have to call it. And then I was just so inspired by that name, because it's, and then the logo, I was lucky enough to be working with a guy named Wes Hare, who is in Portland now, actually. He's a great designer, graphic designer and product designer. But the logo, this is the picture I gave him, right? I was like, it's like a stegosaurus that's happy and has keys. And this is what he did with it, right? And then we just iterated on it and iterated on it. And finally came to,
Just inherently happy.
yeah. Finally came to where we are today. And so once I had that, I was like, okay, now I really have to do this, right? Because I like that. And then I met Kurt, and Kurt was exactly what I needed, because I was going to just cobble something together that was ugly and probably, laser cut or 3D printed or something. And Kurt, thankfully, does not do that. And oops. And so he put together this. The hardest part of making this real, and which we overcame a couple months ago, was figuring out the mating system between these keys, finding the right key switches first of all, and then figure out how we can manufacture the keys. We'd gotten something where we could do like $8 a key, key top, key cap, but multiply that by 34, and suddenly like it's not looking that economical, right? So we got this down to a place where we're happy with it. There have been a lot of steps along the way. Let me just show you some shots from Kurt's shop. This is a very recent run of keys. He's testing out his machine. This shows a halfway point where the keys are being milled out on one side, and they'll be milled out on the other side, and they all kind of fall apart. This is the mill that he recently bought that we'll be using to manufacture everything. This guy, which is here, if you want to see it, I just got this today from him. This is an MDF, medium density F, fiber. That the final thing will be bamboo probably. But this is I think a release candidate for what the size and shape will be, and the PCB printed circuit board will be in there. You can take a look at that. And what my job, what I actually spend most of my time doing is crowd supply, which is a crowdfunding company for products. We're kind of a product development as a platform, right? And I co-founded this almost 2 years ago, and when I co-founded it, the reason I was so interested in doing this is it's bringing products to life, right? It's crowdfunding physical things that you have to ship to people, or that you have to make, that you have to prototype. And the reason I was so excited about it was because I was like, I have a lot of things like that I want to do, and maybe I can do them if I do this job that helps other people do this. And of course, I spend my time doing my job and not my own projects mostly. But it has really helped. I met Kurt through this. I met a lot of people in the, especially local community. Got a lot of good manufacturing advice. But anyway, if you have a physical thing, or if you know somebody who's making a physical thing, we'd love to talk to him. And this will be launched on Crowd Supply, hopefully either end of this month or next month. You can find out a lot more than I've said, and spoken by people who really know what they're doing with stenography at the Open Steno project. I'm one of the co-founders of that, Mirabai, Heskey, and somebody just joined, actually. He made another, he beat us to the punch. He made his own 3D printed do-it-yourself kit for stenography, for making a stenotype machine. You can get that through there as well. But also, if you just want to learn more and see videos and answer the questions that you had about, like, well, how do I do this word or that word? There's a mailing list, there's a wiki, there's all sorts of support. It's very friendly, so you can, you can just dip your toes in. And of course, you can sign up at stenosaurus.com to find out more information about all this. I'm sure I missed a lot of stuff. I'm happy to take questions and talk about things. Yeah.
Do you see potential for applying this to like mobile phones?
Yeah. Yeah. That was one of the things in the list of 6 that we think is, the main reasons of getting into stenography, right? I can imagine a split keyboard. First of all, there are split keyboard steno machines. This one isn't. I think the next version will be if I do a next version. And then the trick is, well, just how do you integrate it? Do you put it like here on your thighs, or do you keep it in your hands, or?
Right. I guess I meant like, so we see like the digital version of the keyboard now. Like, could you, if that was the steno keyboard?
There are applications that you can run on a tablet, or I think even on your phone, that do emulate stenography. It turns out the physical feedback is really important, right, for stenography. Yeah. But people do use it, I guess, mostly for toying around with or practicing while they're on the subway or whatever. I can imagine something where it's on the back of your phone, and I think there are keyboards made for, there are a couple of things that haven't really made it to the mass market, but the keyboard's on the back of your phone where you're kind of holding your phone like you always do, but now the back of it is useful, right? I could picture something like that. Yeah. 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 The way you start is you get a default dictionary, and this dictionary is the canonical dictionary for your theory that you learned, right? So everyone who has learned this theory has started with this dictionary, and then as you progress in the theory, and making up your own briefs and kind of and getting your own domain experience. So if I'm in a law room one day doing a certain type of court case, I'm going to use a different dictionary than if I'm in a classroom transcribing history, right? And that's very common to swap out dictionaries. And in fact, that's what this slot is for. It's an SD card slot. And you might have all your dictionaries on that and just toggle through it. Another point out is this one. This LCD screen up here, you'd think you wouldn't really need it because you're just looking at your computer screen. But if all the intelligence is in here, your computer screen doesn't know what's going on, right? It has no idea that stenography is happening. And so you need a way to input new words on the fly, right? New definitions on the fly. And that's really important for stenographers. So if you hear a new phrase or a new word and you're like, oh, I need to make up a brief for that in my dictionary, then I would look down real quick at this screen and I would type in something, the English version, and then the chords that correspond to it. So as I do that more and more, my dictionary evolves and diverges from everyone else's, right? And I'll develop my own preferences for how to do that. And it's, anytime you get two stenographers in the same room, they're always kind of arguing in a polite way which way is better, right? Like, oh, well, you should really brief that phrase or this type of word this way and not that way, right? So that's how, and so in the end, a very experienced stenographer will have a very different dictionary than their peer, but they might be able to look, and as I said, kind of as Spanish can sometimes understand Italian, or parts of Italian, understand some of their dictionary. Yeah. Yeah.
The increased input speed, is it create an issue for like the machine you're inputting into? Do you need a faster computer, or does it not
No, we're really slow compared to machines. So, yeah. Yeah, I don't think there's anything. I mean, most computers don't do anything most of the time, right? They're just waiting for us. We're super slow. I mean, they're operating at gigahertz, and we're hertz. So, yeah, there's been no problem doing that. Back a long time ago, that was a problem, but not anymore. Yeah. Yeah.
So this might be out of the scope of what your understanding is, but so phonetically as you're recording, like is it broken up? How is it broken up by key? Is it just like
And this is the edge of my knowledge essentially on this, but there's no markings on the keys here, right? But you could put markings here that would make sense, and they're English letters. They're all consonants here. They're A, O, E, U, I think, or A, E, O, U on the bottom. This is S, and then I think Z is down here. This one finger, your right pinky finger, does double duty. It's the only one that does double duty for this, 2 columns at once. You might press these two. So different. There's a limited number of consonants here, but the combinations of those consonants make other consonants, right? So if I press this entire column down, that's different than pressing just one of the keys. So eventually, you it obviously spans the entire space of English phonemes, or at least how we can enough of the space that we can create all of the words out of it. And sometimes it's obvious, like the S might be the S sound, but it might also be the J sound or something. And this is where I don't really know.
There's something really cool about seeing a keyboard without any letters or notes on it. Like it's very different from anything else. Like all buttons have labels.
Right. Well, there's no stenographer that doesn't type touch, or touch type rather. You're never looking at the keys, right? You're just flying. You're just no, because you're not moving your hands. There's no need to. There's 3. Oops. I'm often moving my hands just, even if it's just a centimeter in every direction, but that's enough for me to get lost, which is why, and I touch type and I rely on the little nubs on the J and F keys to know where I am. But with this, you don't really need that at all, is my understanding. Yeah. So to give you context on how long it takes to learn, I mean, even to me, it sounds like a very formidable task still. How do I pick this? How do I go from what I know to this and be productive? There are people on the mailing list, part of the Plover community, who say, I just do this 30 minutes a day, and I'm up to like 40 words a minute already, right? And my conjecture is that in the same time it would take you to pick up and become as good as you are right now with your QWERTY keyboard, in a Dvorak keyboard. So people often make the switch between QWERTY and Dvorak. And in Dvorak, you're getting a 10% boost in speed, typically. And a lot of people do it. The people I know who did it because their wrists were hurting. And they said, OK, I need to learn how to type more efficiently, so I'm going to switch to this Dvorak keyboard. So they went cold turkey, and they just used Dvorak. And the reason their wrists got better, I think, is because they couldn't type very much. Right? They just weren't very good at it. And so for about a month or 2, and then eventually they got better at it. And I think they were just more cognizant of not injuring themselves again. And it is slightly more efficient. But for the same effort that takes, so a couple months of work, I think you could get easily past your typing speed on a Steno machine. And then the ceiling is way higher, right? So if you really were determined, you could get up to that 250 words a minute, right? And then you could be a professional stenographer. Or you could just be happy at 100 or whatever. So I'm really hoping to inspire those people who just want to be faster and more comfortable, but not professional speed, to try this out. I don't know. And to that end, I'm actually working with, there's the guy who holds the world speed record, Mark Kislingbury, I believe his name is. I've talked to him, and and we might have some sort of collaboration with him. He has his own theory of stenography, which is very speedy. There's a guy here locally who runs the biggest online school for stenography. He's here in Portland, just coincidentally. And actually, he made a documentary about Mark Kisling-Berry called something, called For the Record, or yeah, something, some pun on stenography, right? So talking to a couple different people who are in the stenography community already, they're really interested. Ostensibly this could be like severe competition for them. I'm not really gearing it toward that. I just want it to be out there, but they've all taken it as, wow, this is great. Our profession is kind of dying and needs something interesting to get more people involved. And so they've all been really receptive and helpful, which has been a big boon to the project. Yep.
So I imagine this works in other languages too, but what about like Japanese or Chinese or?
Yeah, the stenography is very specific to English, right? This keyboard is very specific to English. There are people who, to my surprise, that was one of the first real directions of interest for Plover, was people trying to use it for Polish or Czech or other languages. And I know there are a bunch of people doing other languages with it, or with stenography, or trying to create systems. And it seems to be working. I don't know. I know there are, I mean, Chinese and Japanese, the whole character system is somewhat like this anyway, right? There's so you kind of combine different radicals, right, to make other characters. And their keyboards kind of work like that anyway. So I don't know if it would be, I don't know if it could be concise enough to be used with this keyboard though. And it's a much larger space, right, than what we have. Although the phonetically, it's actually much simpler. Both Chinese and Japanese are super simple phonetically, right? There's only, English is way more complicated. But I don't know of anybody who has actually done that yet. Yeah. Okay. Well, feel free to come up and check out the props. Thanks for everyone's time, and yeah.
Thanks, Josh. We return on December 2nd with Allison Jean Cole of the Mount Hood Rock Club, and her talk is Rocks, Minerals, and Lapidary Craft in the Pacific Northwest. And here's her thing. I think it's done in first person again, so imagine that I'm Allison. The Pacific Northwest is home to some of the most famous gem quality agates and jaspers on Earth. It is also home to a strange creature not unlike a Sasquatch called a rockhound. Rockhounds are avid explorers in search of fossils, rocks, and minerals in their native environment. No forest road or desert wash is too treacherous for a rockhound to dig. Dynamite usually fixes most problems. In this talk, we'll explore the stunning variety of psychedelic rocks and minerals that hail from the Pacific Northwest and how they're formed. We'll also cover lapidary traditions, tools of the trade, and how newcomers, like Allison, I changed it, see, are changing the perspectives of an old school craft, such as making diamonds in the microwave.
Cool.
So that would be great. Let's have another round of applause for Josh.
Yeah. Thanks. Thanks, guys.
That was excellent.
Oh, cool. Thank you.
Yeah.
Thanks a lot.
So is this of the with it?